Welcome back to another Algebra 2 video. I'm Mr. Hibble. Today we're looking at section 2.5 in our notes. This is all about solving systems of equations. Today we're looking at our second method. We already previewed substitution in the last video, so if you need to watch that, go back and watch that. But today we're looking at solving using elimination. How solving systems using elimination works is we first need to start with a definition. Okay? Definition that we need to know is what the heck are opposite terms? To put opposite terms in the easiest kind of way possible, the most simplified way I can explain it. Opposite terms are simply the same term, right? So if it's an x, it has an x. If it has a number, it's the same number, with one small difference. They're the exact same term, just with different signs. So if I have a term, let's say 2x, its opposite term is negative 2x. If I have a term negative 7y, its opposite term is positive 7y. Opposite terms are the same exact term, number and variable, just with different or opposite signs. Well, there's an interesting thing that happens with opposite terms. For example, if you add opposite terms, the same thing always happens. 2x plus negative 2x, they're like terms, so we can combine them. And when you do combine them, they end up canceling out and giving you 0. Same thing with negative 7y plus 7y. When you add opposite terms, they always cancel. Well, that helps us out if we're solving a system, because if I have opposite terms, for example, 14y and negative 14y, I see that they're the same term, just with different signs. Well, what I can do then is I can add these equations together. We said that opposite terms always cancel, they go to 0, so the y's are now eliminated. Hence why this is called solving by elimination. You eliminate a variable. Okay, but if we're adding these equations, we have to add all of the parts. I have to add all of the like terms, 10x and 9x. Those are like terms, where if I add them, that's 19x. Negative 10 gets added with negative 9. Again, those are like terms. You can combine them, you can add them together. Well, by doing that elimination, all I have now is 19x equals negative 19. I can divide on both sides and solve for my first variable. We end up getting negative 1. Well, remember, thinking back to our lesson about substitution, if you know what something's equal to, you're allowed to always plug that in. So if I look at either of the two original equations, right? If I look at the original two equations up here at the top, it doesn't matter which one I use. It doesn't matter which one I plug into. But when we do plug in, choose the easier equation, right? If I have 10x and 9x, the 9's smaller, I might choose that equation to use. Okay, but the bottom equation also has more negatives, right? So I look at how big are the numbers and how many negatives do you have. That's how I determine which one to plug into. This one, they seem fairly similar, right? They both have similar size numbers. They both have negatives. Plug into either equation, you get the same thing. I'm going to plug into the top equation just because it has less negatives. When I have 10x plus 14y equals negative 10, we said we're plugging in. So that means I get rid of my x variable. I replace it with the value that I know it is equal to. And then I can just go ahead and solve using our normal solving process. If you need help solving, look back at some of our older videos. Some of those videos should help when we were looking at solving linear equations. But we moved things over by doing the opposite, by doing the inverse. So we were subtracting, the opposite is addition. Now the 14's multiplying, so I divide. We end up finding our solution is negative 1, 0, x, comma, y. You can always rewrite your answer as a coordinate when we have x and y. That's the basic kind of example, and some people like that process because, personally, I think it's easier than substitution. That's my personal preference. I like getting rid of stuff, not plugging in more stuff. I like making it more simple. But when I look at this next equation, what I notice is there's not any opposites now. Okay, that's fine. That's fine. We can create opposites, right? If I don't have them, maybe I can do something to create them. And it's actually not terribly hard to create opposites. What you can do is you can multiply one of your equations by something. What I'm noticing right now is I have negative 4y and I have negative 12y. I know that if I multiply 4 by 3, that will give me 12. So let's see if we can create our opposite terms right now. So when I take this 3 and I'm going to multiply, that 3 multiplies with everything. It multiplies with the 5. It multiplies with the 4y. It even multiplies all the way to the other side of the equation with the 30. When you do that multiplication, make sure you multiply with everything. Most people's mistake is they don't multiply to the other side of the equation. Okay, so I'm all excited because I think I made my opposites, but when I go to add, I have negative 12y and negative 12y. So something's messed up. I needed positive 12y, right? Because the opposite terms are different signs. So how can I make the negative 12 on the bottom a positive 12 instead? Well, all you would have to do is multiply by a negative 3. A negative times a negative is a positive 15. A negative times a negative is a positive 12, just like we wanted. And a negative 3 times a positive 30 is now negative 90. Now we can add our two equations together. The y's are eliminated. We can combine the x's. Negative 4 plus 15. That would give us, that looks like an 11x there. Combine the other side. Negative 20 plus negative 90 is negative 110. And you can go through your quick solving process to find the first variable. Once you find one value, plug back into one of your two original equations. So if I have these two equations that are highlighted now, I can plug into either of those. Doing so, we know the x. Doing so, we know the x. Look at which equation might have smaller numbers. I like the bottom equation personally. Realize your y will not always eliminate. Sometimes you eliminate the x. It's whichever one works out easier. So now when we're solving, go through your process, find your value, and get your final solution. It looks like in this case, we're going to end with a value of 5. So our solution then, negative 10, positive 5x, comma, y. There we go. So when we go through this process, the first one had opposite terms. The second one, we made opposite terms pretty quickly by multiplying one equation. Let's look at this third and last example for this video. On this one, what I notice is 2 does not multiply into 3. 5 does not multiply into 6. So I can't necessarily multiply one equation by something to create opposites. But what I could do is multiply both equations. That is allowed. Well, if I do that, I know 2 and 3 multiply into 6. If you don't know what they both multiply into, one trick you can always use, just multiply them by the other value. So if I didn't know 3 multiplies into 6, I would just multiply it by 2. If I didn't know 2 multiplied into 6, I'd multiply it by 3. Okay? But same idea, they both do multiply into 6 here. We can go ahead and go through with this process. 2 times negative 3x. Continue your distribution. And now we have this. Let's look at the bottom. Let's distribute there as well. See if we did create opposite terms or not. Notice I do have 6 x's, but they're both negative. If the signs are wrong, again, just multiply with a negative. It doesn't matter if you multiply the top or the bottom one with the negative to flip the sign. I'll just multiply the bottom one with the negative to see what ends up happening. The 6 is positive, the 18 is negative, the 36 is positive. Go through your process then. Now that you have opposites, the opposites cancel. Combine your like terms then, going down. and solve. As you do that, you should find y equals -2. Plug back in. I would use the two original equations. You don't need to use the bigger versions after the multiplication. Those would still give you the same thing, but they're the same equation, just a little bit bigger. So I would use the smaller values personally. Now that we have the y value, last thing we need to do is just plug back in. Let's go ahead and do that. Again, like I said, does not matter which. Make sure you're replacing the correct variable. It looks like we have y this time, so make sure you replace y. Top equation might be easier because there's smaller numbers, but you also have more negatives. Just choose the equation you want to work with and just start to go through that process. As we go through that process, we are just moving our values to the other side and finding our final answer. It looks like x is equal to 0. There's our solution, 0, -2, x, y. Thank you for watching. That is 2.5, solving systems using elimination.